we're going to look at an example of a parametric equation here. So they want us to sketch and identify the curve that is given by these two parametric equations. So notice x and y here, both our functions for x and y depend on some other parameter, which is t here. So what we're going to do is set up a table. T is our input variable, and both x and y will be our output values. So let's start with x. If we put in -2, our first number here, in for t, what does t become? Well, it's just solving out a little equation here. -2 squared is going to be 4. -2 times -2 is also +4, so the output value would be 8. And then we're just going to continue down and find those numbers. So if we did it the same thing with 1, we'd have 1 plus 2, which would be 3. If we put 0 in there, it's going to be 0. 1 minus 2 is going to be -1. If we put 2 in there, 2 squared is 4, minus another 4 would be 0. And if we keep going, you get these values. Now let's do the same thing with y. So now we're plugging -2 in for this y to figure it out. So if we add 1 to that, that's -1. And we're just going to keep basically adding 1 to each t value here. So this would be 0, 1, 2, 3, 4, and 5. Now what we want to do is graph this out. So we're going to create a graph here. And then graph these points. Let's start with the first one. So we graphed with the parameter of -2, we get the point 8, -1, which would be right here. Our second point, when we put the parameter of -1 in, we get 3, 0, which is right here. Putting 0 in, we get 0, 1, located there. 1, we get -1, 2, which is here. The next point gives us 0, 3, 3, 4, which is there, and final point 8, 5, which is here. So if we connect these, there's our graph. And this one, as we were graphing those points, the direction that it was moving was this way. So what you want to do when you're graphing a parametric is also indicate the direction that those points are moving. All right, so here's another look at that graph, kind of like we just got. They want to know, is this graph a parabola? Well, it definitely has that parabola shape to it. It's kind of a U shape here. Also, to determine that, if you look at the table we just had, you can see that it is kind of a sideways parabola here, because there's our vertex point. Notice how it's symmetrical on both sides. So I do think that, yes, this is a parabola. How can we find out for sure, though? What we're going to do to find that is find what's called its Cartesian equation. And the Cartesian equation, when you graph in the Cartesian plane, that's an XY type of equation. So can we come up with an XY equation for this one? We can, and the way we can do it is through substitution. So what we're going to do here is substitute one equation in for the other and see if we can come up with that Cartesian equation. If I look up at these functions here, the easiest one to solve for that parameter would be this second one. So if I minus 1, it tells me that t would be equal to y minus 1. So what we're going to do is take and substitute out that parameter by substituting in now for t. So then our equation here, our Cartesian equation would be x equals y minus 1 squared minus 2 times y minus 1. And then if we simplify that, y minus 1 squared means we got to multiply 2 y minus 1s here. Here we're also going to have to distribute a -2, so -2y. -2 times -1 would be +2. If we keep going here, you get y squared minus a y minus another y plus 1. And finally, combining like terms, we get this equation. So is this a parabola? Again, yes. This is in the form of a parabola. It's a quadratic. So we did in fact get a spelled it wrong here. Quadratic. We did in fact get a quadratic. It's in that form of it's in the form of a quadratic that we've seen before, except it's y instead of x. It's on its side. All right, what would the function look like if we graph, or if we took a look at the graph just from a time of 0 to a time of 4? So instead of starting at -2, which we started at here, what if we just started here? Well, that would kind of just wipe out this part, because we won't be finding that anymore. And the graph would then look like this. So now our starting point is 0, 1, and we're ending up there. It still has a direction to it. We'd still be moving in the same direction that we started with. It's just the graph is not going to be as big as it was before. Some final terms that you're going to hear when graphing some of these parametric equations is your starting value and your ending value have a name. The starting value is called your initial point. So this one where we just graphed from a t of 0 to a t of, what was it, 4 would look like this. So this would be our initial point. And then at that's at t of 0. And then up here at t of 4, we get to 0.85. That point is referred to as our terminal point. So this would be our terminal point. And terminal means like end, where something terminates is where it ends. So the starting point is your initial, or starting value is your initial point. The ending one is your terminal point. And again, it has a direction to it. It's starting here and moving towards our terminal point. So when asked to find those things, that's what we're looking for.